Hey everyone, Brian Beeler coming to you with the storageReview podcast. This week we've got a really great conversation with Andrew Pratt from Ducks Unlimited in Canada. And I met these guys at Veeam back when we could have events, back in Miami last year, and had a really interesting conversation about challenges with computing at the edge. And when they're talking edge, they're talking very remote edge. So there's an interesting conversation here, and I think that as we think about these workloads growing and pushing more out to the edge, that not everyone means the same thing. So let's bring in Andrew. Andrew, thanks for joining today. I appreciate it.
Anytime.
So we know a lot about ducks. You know, what are you guys doing up at Ducks Unlimited Canada, though, to set the scene for our listeners?
Well, Ducks Unlimited Canada is a fairly large not-for-profit organization, and we've been around since 1938. So we're an old company that's got a lot of deep roots, both figurative and other, in doing fundraising, conservation work across. We started in the Canadian prairies. The very first Ducks Unlimited project anywhere in the world was about an hour or so east of where I'm located, or west of where I'm located, in Winnipeg. So that's kind of the start of DU Inc. in the US and DU Canada here. And then from there, we kind of spread across the entire continent, doing conservation work and grassroots fundraising and creating conservation for habitat. So a lot of it's wetland related.
Yeah, is it mostly wetland preservation? I know there's a broad scope, but if you had to boil it down, is that
fundamentally we're a wetland conservation company, and then sort of the tagline is an associated uplands that support those. So
right.
Most ducks breed actually on the upland and then use the nest or the wetlands for sort of a food source.
We got to talk about the Canadian geese. We've got a couple ponds in our neighborhood, and those guys make a mess, and they're a little bit rude. Honestly, they're hurting the image of Canadians overall, I think.
Well, I guess we should clarify, they're not Canadian geese, they're Canada geese. They're named after the biology of the country. You can't blame Canada for that one. But interestingly, a lot of why Canada geese are doing so well, as opposed to, say, snow geese or other species, is they're very, very adaptable to humans and human influence. And they really like short manicured grass. So if that's why they're in golf courses and a lot of the urban developments that have sort of the retention ponds with that perfectly manicured grass. To them, that's ideal habitat.
Why? What is it about the short grass? Because yes, you see them on every golf course, but they cut the grass weekly around the pond too. So of course that qualifies. What is it about the short grass?
Well, a lot of it's they're eating the roots, so they dig down and eat roots, and it's easy to get at a lot of the sort of the associated like critters and insects and whatnot that are at that surface. So when, as part of Ducks Unlimited, one of our sort of side projects is we will build and design the retention ponds in urban environments in a more natural state, so that you have tall native grasses that are self-sufficient, and they act as a good job of soaking up some of the nutrients that are rolling off people's lawns. So you end up with a healthy ecosystem that's self-sustaining, rather than a lot of the retention ponds that tend to turn sort of blue-green algae that smell color later in the summer when things get hot. It's because there's the nutrient load, right? So if you build it properly, it self-sustains, and then you don't end up with a lot of the geese problem either, because they don't like that tall native grass.
So it's a better, healthier environment, and it gets rid of the mean geese.
It is, and interestingly, from a developer standpoint, it also increased the cost of the property. The properties are more desirable. So we've been doing this across Canada, and I'm not sure whether it's moving into the US or not, but a lot of the developers are approaching us to help build these, because even if they spend, say, $200,000 to improve and build it properly, the property value in and around it is far outweighs that. So it's a win-win on everybody's standpoint. Unless you're trying to buy a property, then it's more expensive. But
well, that's interesting, and it does seem to be something that with all of these, maybe not in the out in the country where you guys spend a lot of time, but in these planned housing developments, at least all over the States and certainly in the Midwest, where they have to build in those retention ponds, as you say, to be able to do it in a more sustainable, more beneficial way to the animals and creatures around that are largely oftentimes displaced by the housing that's going in the first place. Not that you can put them all in a pond, and a lot of them are deer and other things, but it's a start to make that better, right?
It is, and it's interesting from a marketing standpoint. A lot of people don't necessarily understand, especially for within Canada, we are quite different culturally than sort of the American DU advertising side of things, largely revolving the hunting aspect. In Canada, we really are more focused on the water quality side of things, and it's always a task to make DU relevant to an urban person who doesn't really care about, to your point, there's hundreds of geese. What do I care? Well, it's the water quality and cleaning, and so the lakes and rivers and streams are healthy, and it benefits everyone from your clean water and all the way through. So having some of these urban ponds helps educate and drive some of that storyline and making it relevant to people that live there. Say, hey, imagine this, but on a much bigger scale.
Mm-hmm. So let's get into that, because you are managing or working to preserve these wetlands at a much larger scale in Canada. Your acreage, I don't even know what it would be. It's got to be some insane amount of space.
6.4 million acres, I think, is the last number. It's up there.
Yeah. So you've got the problems or challenges of a traditional business, because you're servicing, you've got a couple sets of customers, and we can talk about that. But you are also doing some stuff, as I teased at the beginning, at the edge. But start off with the core data center. What are you guys doing there, and what are some of the challenges you face as a nonprofit with the decisions that you have to make to support your various entities?
Well, fundamentally, it's cost. So, as you said, we're usually around $100 million company in Canada. COVID's impacted that a little bit, given that we are essentially a grassroots fundraising. So, as you might imagine, the impact COVID's had on a lot of our fundraising stream has been quite dire. But we have the requirements and needs of an organization that has multiple terabytes worth of data on any one given day. We're data rich, data driven. We have a full science team and a full sort of GIS CAD user base that is generating a lot of data and analytics. So we have sort of a lot of data to deal with. We're very geographically disparate. We're from coast to coast. There's 28 offices plus 2 data centers that we need to support from an IT standpoint, which is fine if you've got a fairly sort of robust income statement that's sort of generating that from whatever that business line might be. Ours is a little different in that we're not for profit. What a lot of people don't realize in any not-for-profit space is a lot of the donations you get come with strings attached. And that really doesn't matter whether it's Joe giving you a check or whether it's a grant or fundraising request from the government, whatnot. So for us, yes, we're a $100 million company, but 80+% of that is saying, no, it has to be spent on these projects and only these projects. Mm-hmm. So you've got a very thin slice of the pie that's left to support everything else, all of your admin costs, which include IT.
So let's talk a little bit about that data that you're collecting. Some of it is way out at the edge, and I know you were working on an IoT program for that, so I want to talk about that. But what other types of data is it that you guys are gathering, analyzing, and then what are the kind of fundamental decisions that come out the back end of that? So we'll break that into 3 steps. Let's start with the data that's coming in. What's the primary source of data for you?
It's an interesting question, because from where we're going to end up talking about, there's different aspects of it. So there's quantity and quality, and sometimes those are related and sometimes they're not. So we are essentially 2 or 3 different companies joined together, right? So we are, as a not-for-profit, a fundraising company. So we have a full arm of the company that their job is to raise revenue through grassroots. So we're in things like Salesforce and Classy and the various pieces that plug into making that side of the business run. So there's a lot of sort of CRM related data that we're gathering constantly to analyze patterns and figure out how can we be more efficient in the fundraising side. So that generates a lot of volume, but it's not, it's fairly small in terms of footprint and storage. And it's all pushed out into various cloud apps like Salesforce, for example. The other sides of the business is conservation related. And for that, there's on the ground conservation, and then there's this full science team that's generating the why and the how and what's the most efficient way to do our conservation work. So much like we're doing sort of similar work on the CRM side to find what's the most efficient way to run an event, there's also a science team that's saying what's the best way to do this kind of habitat work. So we've got a team of full PhD scientists that are running things like SAS and R and data analytics and gathering sort of their science projects. And then we've got our GIS team, which is sort of near and dear to my heart because that's the team that I've sort of spent the better part of my career building, maintaining, and owning. And that generates about, from a volume standpoint, about half of the data that sits in our data center is this GIS CAD kind of data. And interestingly, a lot of it is imagery, and that stuff just doesn't compress, and it's multi-terabytes in size, and it's difficult to manage and deal with. And as a company that has adopted a cloud-first strategy, it's a real detriment to say, okay, it's easy to say, okay, I'm going to move my full CRM up to Salesforce in the cloud, and I'm going to move my finance system to Dynamics FO, and I'm going to move this system to some cloud system. It's much different when you say I need to move 20 terabytes worth of this GIS CAD data into, say, Esri's cloud, because there's a significant cost of moving that much data up there. So that's been a challenge, is just saying, so as a result of that, you end up making some decisions about, well, I still need to maintain my own data center and with my own storage and my own backups, and then with the data backing that up both locally and to a secondary data center, et cetera.
So you want to be cloud first, which makes sense, and then you've got some of this weighty image data that makes at least that part of the business difficult, because it's data transport, I guess, would be part of it, and maybe you can talk about that a little bit too. But also just the cost of terabyte and running analytics in the cloud on that stuff is hard as well. Is that mostly, what is that? Is that satellite data? Or are you guys sending planes up and getting, data or photography relatively often on growth or shrinkage of certain wetlands? Where's that coming from?
Yes.
All of it, huh?
All of them.
Okay.
We're using, at a grassroots level, most of that is imagery that we're acquiring. That's often it's airborne, and it's similar to like a Google imagery kind of quality. There was a concept that was floated around 10 years ago that sounded fantastic. Everyone's going to move to a subscription model, and we'll just stream all of that data and you won't have to store it. The reality is that we're still waiting for that to happen. So most of that we're acquiring on sort of DVDs or now on sort of hard drive based, and it's multi-terabytes at a time. Oftentimes it's because we're doing wetland inventory work where we are having to fly and get stereo imagery so that we can in 3D view the landscape. So it's not just a flat 2D image, it's in 3D stereo so that you can then draw the contours of a topography map and see basically you're mapping basins so you can see the depression versus just a flat surface that you're saying, well, that's the edge of the lake. Well, it's sometimes very difficult to map. Lakes are fairly stable. If you think about a wetland, though, even wetlands tend to be fairly transient in that in dry seasons, they may be completely dry, and in wet seasons, they're flooding their banks and everything in between. So depending on when the wet cycle is, or when it happened to rain, is it spring, is it fall, it can be difficult to use water level as that's the different basin. So then you end up moving into this 3D stereo world, which requires then two images for every one piece of property, because you need sort of one view in one way and one view in another way, so you can generate a 3D image. So then you're doubling the amount of data. So that's one aspect. We also have things like drones, where we're flying drones on our properties for whether it's inspections or whether it's doing sort of recon work where we're saying we might want to do a project on this property. Not really sure what's here. Let's take the drone and fly it. And then we can take that image and create a surface to say, oh, these are all the various depressions. This one was drained. If we put a plug in here, we can sort of restore this and those kind of hydrological evaluations.
How much of that is done? Obviously, you've got your science team. How much of that is done by analytical science? How much of it is intuition? Because I'm just thinking about, of all the applications and uses of AI that are talked about all the time, that this seems like a pretty good candidate for AI. Are you guys doing anything there, and can that help you do this type of analysis faster, or is it still too much of a trained eye that needs to see this stuff?
It's evolving, and in many ways, it's becoming, which I think a lot of us kind of understood from the beginning. What would happen is that it's a hybrid. So, and say if we step back, say 15 years, it was pure manual. It was one person that sat down and hand digitized or drew the boundary of something because they were the AI engine, right? They were using their eyes and their brain and the understanding of maybe it's field work to say, I know where the boundary of this is based on the things that I can see. Mm-hmm. That's very precise but inefficient. Versus, so we had the idea, well, we'll just train an AI engine to do the same thing that the human was doing. And the reality is it can't. There's just too many variables at play, even within one ecosystem between this wetland and one beside it for various reasons. But what it can do is get you close. And so that's kind of where we're at now, is we'll take a sort of a raw image or multiple series of images, throw it into a decision tree kind of software, eCognition being kind of one of the more popular ones. And you throw all those things in it, and at the end of it, it spits out almost like a probability map that says, this is likely the most area that is, say, a wetland, and this one's a tree, and this one's a house, and based on all of these various inputs. And then from there, you hand that to an analyst, and then goes in and basically cleans it up or does a QC process on it. So you're kind of getting
save some time, right?
Yeah.
Yeah. Huh. That's interesting.
Ultimately, we're looking at things like Google Earth Engine, doing some of this work in the cloud, and trying to shorten how much time or how much cleanup you have to do. Because as you might imagine, if you're trying to inventory all of Canada or even a province or even a state, that's a lot of data and it's a lot of sort of cleanup. So the closer you can get to having as little cleanup as possible is the ideal state, especially if you say, you know what, now I want to do this on a fairly repeat cycle so that I can detect change, whether it's a wet cycle, dry cycle, climate change, who knows what, right? But I want to say, I can't wait 20 years between the last time I did an inventory. I need to be doing this every 2 or 3 years. Well, in that case, you need to automate.
Yeah, I mean, you just have to trim some of that work out of the process. So for the work you guys are doing in Canada, how much sharing is there with the teams in the US or other Ducks Unlimited entities throughout the world? Is there some collaboration there? And is there, even beyond Ducks, is there additional collaboration between other organizations that have a similar preservation message? Like, how, I would think you guys would be able to collaborate and learn there. Is that the case? Or
on a lot of this wetland mapping inventory work, yes, we're talking to, so every last fall, we have a sort of, within Canada, we have a fall meeting of sort of our GIS team annually to get together and share ideas and things. And then last year, we opened it up to sharing with DU Inc. and DUMAC. So there's 3 DU organizations, Canada, the US, and Mexico, all facing very similar challenges, all kind of doing similar work, perhaps for slightly different reasons and different geographies. But so we all got together and kind of discussed these things. So yes, there's collaboration between the DUs, but we're also talking to other agencies that are doing different work. And with our research team, they're plugged into sort of the graduate schools and different people too, and trying to figure out, we're all chasing kind of the same kind of thing. So yeah, there's a lot of collab that goes on.
All right. Well, that's good, because hopefully that'll accelerate your ability to work through this data and sift out what's relevant and then make some decisions based on that. So one of the things I know that you guys are doing that's really cool is this IoT program. Walk us through that a little bit, because you guys, if anyone knows what like the hard edge of technology is, I mean, you guys are out there quite literally. Sometimes a guy that's hiked in several miles or whatever the kilometers are, right, to be able to get to these points and get this photography that you're talking about, and to monitor water levels and all sorts of other things. So tell us about this, because I think it's really an interesting program that you're working on.
Sure. So last year we started a pilot to see, basically to prove that we could do what it is that we thought we could, both in terms of sort of an internal sales and to other partners as well. But the reality is we have a little over 12,000 habitat projects that range from like half an acre to several thousand acres and kind of everything in between. And they are located in almost every province, territory, and ecosystem you can imagine, from one coast. So we've got sort of coastal projects, we've got small urban ponds, we've got large dams, we've got places that are up near the Arctic Circle, and kind of everything in between. So we do struggle to get to all those projects, and so that's where we're using some of this remote sensing satellite views to keep an eye on some of these things remotely. But that's often not enough. You need to get boots on ground, or at least have some sort of quote unquote eyes on some of these resources. So we spun up this IoT division thinking that, well, if we could monitor even just the water level, so on a project where we've got sort of a dam that's maintaining water at 15 feet deep, if we had a water level sensor, keeping an eye on that, and let's maybe add some temperature so we can make some assumptions that, hey, the water levels are fairly stable, then things should be fairly good. If things are going up, then is that because it just rained, or is it because most of these dams have some sort of gauge that lets water through because it's on a riverine system, right? So you need to have some water through. But if they get plugged with either beaver debris or vegetation or something, then that level starts to climb, which for us can turn into a really bad scenario where you get enough back pressure and it sort of damages the dam.
Right.
And then obviously it gets very expensive, and the repair work in some of the places due to just remoteness is fairly expensive.
Uh-huh.
So the reciprocal side of that is water levels that are dropping. Is it, again, because it's really hot, we haven't had any rain in 3 months, like that makes sense that it's dropping, but is it dropping quickly and it's leaking, and so we need to send somebody up? So that was kind of the thinking around the genesis of the why. So then from there, we started to talk to various industry partners and figure, okay, what hardware might make sense here, given that I don't have power, I probably don't have cell service, and I'm going to be in a fairly remote places, so I don't want to have to go back out and get it. So it needs to be able to withstand.
I was just thinking, like you're talking to your partners, and I can just see this meeting happening. Like, well, I want to measure depth and temperature. They're nodding along, and they're like, yeah, no problem. We've got sensors for that. That's easy. And then you drop on we have no power, we have no internet connection, and it's in a relatively hostile environment. Enjoy. Yeah. What do you have for me?
Yeah, so you've got bugs, you've got critters, you've got potentially people if it's too physically big. So like a big solar panel, honestly, it's either going to get stolen or get shot. That's the reality. It's really small, but it also needs to withstand our Canadian winters and our summers. So you've got extremes on all over the states. So that was, as you may well imagine, a iterative project with a few different vendors to come up with something that works. What we ended up settling on is a fairly small package that has sort of lithium batteries. It has onboard solar panels. It has Iridium satellite service. So with that, I can put it anywhere on the planet as long as it has sort of a south exposure for the solar panel and an unobstructed view of the sky. It'll work. So that was really good. We've run into some challenges just on sort of the data side of that, just in getting that data into a format that makes sense for the end users. But that's really on the dashboard side of things. So we're continuing to look at different ways to make the data relevant to the people that need to understand it.
So what did you end up with in terms of the payload then? You've got lithium batteries, you've got the satellite service, you've got a solar panel. I mean, are we talking shoebox? Are we talking a server size? Like what's the physical thing?
The actual box is maybe 1.5 inches sort of wide by maybe 4 inches by about 14 inches. So it's a lot smaller.
Pretty teeny, yeah.
It's pretty small. And we had it color coded, like the plastic molding around it was sort of a beige gray, so it fades into the environment. So from a footprint standpoint, it's fantastic.
Yeah, that's pretty cool. So how many iterations did you have to go through to get to this one that's working pretty well for you?
Once we moved out of our back of the lab using like Arduinos and Raspberry Pis into sort of the serious world, it wasn't very many. I think there was really two two main ones that we went through, and then once we settled on this current one, it was the case then of just working with the vendors. Okay, what options do we have, and can we change the color? Can we make this box this way? Can we do that for different mounting? So am I mounting this to a pole? Am I mounting this to a building? What does that look like? So went through some sort of just minor logistic stuff on that, but luckily I'm handing these out to engineers. So like, okay, I'll do my part. You guys are engineers. You figure out how to actually mount this thing. And they're being pretty creative in making that side work.
Yeah, I could imagine just how that works. So you get one of these modules, you'll send somebody out, and they'll rig it up to, whether it's a dam or something else, to be able to collect this data. Now, the connectivity, though, is something that's really interesting, because it's a lot easier if you're going to stand up IoT devices in a factory or something like that, where you have all the luxuries of electricity, internet, and no beavers to mess with your IoT devices. You're using the satellite connection now. How much data are you pushing, and what kind of data are you pushing back to the data center?
So it's really not a whole lot. They take hourly readings, and they're measuring ambient air temp. They're measuring depth from the top of the sensor. So it uses an ultrasonic sensor. So it sends a pulse down and records in millimeters the distance between whatever it's bouncing off. So hopefully water, and the sensor in millimeters, and battery and a few other minor variables. So it's a very small payload that it fires up once an hour. So it's really not generating a lot of sort of data volume. It's just the change over change is what generates that interest of, is it fairly flat, or is it all of a sudden spiking because there's a problem, or what's going on?
And so it's a lot of little files then that add up to give you that picture over time to your data team to be able to make, ask more questions like, did it rain and cause that, or did I can't get over the idea of these beavers just laughing at you over your attempt to tame the wetlands.
And in some places, it's a never-ending battle. So in other places, we've found that trail cams work really well. So I found a vendor that offers me a trail cam that has a cell modem built in. And if you set it up to take a photo once or up to 3 times a day, it's very, very cheap. So we've deployed a whole bunch of these trail cams around in places that are fairly problematic. And then just every day it sends a photo back to the biologist who looks at it and goes, oh, damn beaver's back. I've got to go fix the problem. Pardon the pun. It's got to go back and fix the problem. So it really depends on that conversation with what is it we're trying to do. Are we trying to monitor water levels and chemistries and things like that, or are we just kind of keeping an eye on something, in which case maybe that's the better solution, or maybe a trail cam might be a better option. But obviously, the interesting conversation that I've had is, because obviously the price points are vastly different. But what I need to get them to understand is that if I'm using something like a trail cam, at least right now, it's not smart enough to tell you whether there's a problem. It just is just going to send you a picture. You have to look at it, and you become the sensor. Versus a true IoT platform that's doing the monitoring and the analytics for you, and then will tell you when there's an issue. So the two are quite different.
Well, the technology certainly exists, right, for some sort of AI thing to look at the photo and say, oh, that's a beaver, or it's not, or even tell you how many there are and how big they are and how much they might weigh and all sorts of data, right? But now you've got a different problem of having to transport some of that data, maybe not all of it, even if the analytics are being done at the edge, in a much more expensive device. So the satellite radio works, I guess, well for you now. It's kind of funny because I think about all the enterprise IT events I go to or listen to now, and they're all talking about 5G will come be the savior of IoT and edge computing, right? Because now we can get high speed to anywhere. Well, your anywhere is probably not on the 5G map, would be my guess.
No, it's
so,
not.
So what's the prognosis for you to get faster internet out in the wild? Is it some, you're on satellite now, but the Iridium network, it's not fast, I don't think, is it?
No, but it doesn't need to be.
Okay.
We're just sending essentially a text message kind of payload. So it is an expensive way communicate regardless.
Okay.
So what I'm looking at of potentially replacements for that are some of the low Earth orbit stuff like Starlink that Elon Musk is pushing up, and he's not the only one, he's just one that everyone's aware of.
Sure.
But services like that may well bring the cost of this sort of satellite-based communication down to something that makes sense for some of these deployments, whether we're meteorological station or whatnot in some of these quasi-remote to really remote places.
So it's not even the bandwidth requirement. It's more just simply a cost issue for you guys to be able to manage that. And maybe, I guess maybe if it was cheaper, you might send data more often, or to the extent that the device could support it on its battery and sun schedule.
Right.
I mean, that's got to be a challenge too, right? Because if it's cloudy for too long, you may not get anything for some period of time. Are these devices, your systems, what do they do when they lose power, and can they be brought back up on their own, or how much manual intervention is required to maintain these guys?
Yeah, and that's, for us, that's always the interesting piece, right? And if you think that ideally what you would like to happen, regardless of the logistics of it all, is if I've got a true IoT sensor, don't give me all this noise. Just tell me when I need to do something that's actionable, like change my behavior. Otherwise,
right.
I don't care. Just if everything's good, stop bothering me. So in order for that to happen, you need to push the intelligence down to the edge to the device, right? So that it's making those decisions for you. And if you can do that, then you could potentially, like you said, have a camera that is gathering all sorts of real analytics and then doing the interpretation of that image on the device. And only if there is a decision to be made does it then wake up the communication backbone and send a signal out. Because typically that's what's the most expensive in terms of power of any of these devices.
Right. Mm-hmm.
But when you wake up the Iridium modem to then send a signal, that's expensive in terms of battery power, which then determines how big a battery you need or if they're in solar panels. So it's all sort of, well, I can make this fairly small svelte box, but it's going to come at this cost. It can't do some of these other things. If you want to do that, then I need, at least right now, a bigger box or a bigger battery or a bigger solar panel.
Well, that's a perpetual fight, though, right? So if you want to do more analytics at the edge, then you need more battery, more system power. Maybe those things get more expensive. And with the wily beavers causing problems, maybe they go take all your sensors and hide them, or perhaps people that walk along don't know what they are. I mean, you talked about them getting shot, not maliciously from hunting, I presume, right? Maybe not. Okay, so we've got to be concerned about that. So device cost has got to be pretty heavy on your mind, in addition to having enough power to do your work, right?
Oh, it is, and so there's kind of two aspects that come out of this conversation, and what we're thinking from some of my team long term is, right now the very simplest way to get any IoT project off the ground is convince the people above you that there's an ROI investment here, that it's going to pay off in fairly short order. So for us, the simple answer was, well, let's do this water levels because it will save on staff travel and potentially not have the repair bills, etc. It's a fairly easy, contained, okay, we can get sign off to do that. But where I would like to get to is moving from water quantity into water quality, which is a complete different ask. And when we get into that gauge, it's really looking at the health of a large scale environment. So in Canada, we've got a few large lakes, and this is true south of the border too, right? Where we've got some fairly large systems, watersheds that are draining into a basin. And we know there's a problem because at the bottom end, this lake is turning blue, it's got green, it's not healthy. But where's that problem? Well, it's upstream. But where upstream? So that's where, if we had an array of water chemistry sensors, we could start to indicate, there's something going on over here that isn't happening on that side. And then maybe you get into different taxations, or you send science team in. There's lots of different ways, but it all starts with the data. And right now we really don't have a lot of it. But in order to make that whole system work, you need a lot more sensors, which is where your cost per starts to really add up. And if I want to just be able to throw these in a mail and say, hey, I'm going to send one to every farmer in Western Canada. Mm-hmm. Well, then I need it to be about a $5 sensor, right? It can't be $2,000 sensor. So that's where the sort of the price points really start to come into this. If you want to start to expand this beyond a simple ROI on sort of your own private business stuff. But
well, how has your ROI been on the water level? This initial thrust, is it working out for you?
it is. Some of it is just we don't often, some of these projects we're not there as often as maybe we need to be. So for those, it's just sort of lining up cycles to, oh, we're going to actually be going out to this one, so we'll start to deploy. But generally speaking, I'm now getting more and more requests from our field staff to say, hey, can you get another one? I need another one. I need another one. I've got another use case over here. So yeah, it's starting to pick up steam.
So for your math, if it's mostly travel, I mean, that's a pretty easy line to connect those dots, right? We didn't have to go to these 18 places, and it typically costs us X amount to do that. So we add all that up and see where we ended up. For a more traditional enterprise that's thinking about investing in things like edge analytics and IoT devices, the math might be a little fuzzier there or take a little longer to show that return. Do you have any thoughts on what organizations should be looking at, where to find some of these benefits?
Talk to your end users. A lot of where we ended up with ours and generating that business case, I had my own mind and thought about similar to you. And well, it's simple. It's wait, I know I'm going to cut down on travel costs. But when we actually started to talking to some of the end users, like, well, yes, but some of the biggest costs we have are on the repair side. So if we could find a way to be more proactive than reactive on some of these issues, then we spend a significant amount of money that we could then save and say, before this became a big problem, I was aware of it and I fixed it with a pickaxe and a summer student, versus I needed a cat for 6 months and it was a major political deal and all of this things, right? So that was a different case that I wasn't even really aware or thinking of, because I wasn't as close to the businesses as these guys were. So in talking to them, they gave me a different insight to say, oh, didn't think about it that way, right? So, because ultimately, they are the ones that have to drive the ask.
Well, yeah, and I imagine it provides more broad support for what you're trying to do too, right? Once they start seeing the data for your science teams, to see the data without having to go and collect it. I mean,
yeah, it was interesting too. So to that other point, we have one. A lot of our projects are fairly public, or they've got a number of landowners that surround them, and sometimes that relationship is great, and sometimes it's not, depending on what happens. Right, you always get blamed for it rained and rained and rained, and now you're flooding. Like, well, that would have happened regardless, right? Or you're holding too much water, either positively or negatively, etc. So one of the interesting cases that came out of one of our projects that we had one of these sensors on is we made the dashboard public. And so in the conversations then with all the landowners, like, well, if you want to know what's going on here, like, we're not hiding anything. You can see all the long-term averages and see what's supposed to happen and hold us to account. And if there is a problem, then by all means, let us know, right? So in some cases, just being transparent in your data can help you into other avenues as well.
Yeah, so talk about that, because I think you're right. You get the data, it's all, I mean, it maps it out, but most people don't want to read flat text files to figure out and draw some historical change, especially over, if you're getting one of these every hour times a year. I don't know. That seems like a lot of data to sort through. So visualization of the data becomes important. Can you use, some tool like Tableau, or like, what do you do there to help make the data consumption intuitive for your users, whether they're scientists or interested parties like the landowners you're talking about?
Yeah, well, ultimately, data isn't as valuable as the insights that you gain from that said data.
Sure.
Unless you're, I know some people that are really good at visualizing data from an Excel table, but most of us actually prefer to look at it plotted in some sort of way with something that it helps us visualize that. So in that sense, we have gone through a few iterations of trying to create sort of dashboards that have a map of where the sensor is with the various charts and plots. And that process has been a bit of a challenge in trying to make it as nice an experience as we need it to be, given that everyone's really now, they expect the Google Maps or the mobile app experience where it's all slippery and interactive and it just works and it's pretty. The reality is that costs, in some cases, a lot of money. And so as a not-for-profit, we struggle to give them that experience without having sort of the budgets to make it work, given that as much as you say every hour, every day for a year is a lot of data, it really isn't when you start talking to some of these big tableaus, for example. To them,
sure.
that's irrelevant. I'm used to dealing with like millions of requests a minute. That's when you get sort of the price points and price breaks that we would need, but we just don't generate enough data, and frankly, never will.
I guess you need more ponds or more beavers causing trouble, huh?
Sure.
Since we met at a Veeam conference, I feel somewhat obligated to let you talk a little bit about what you do with the data. So you've got a lot of your apps in the cloud and you're consuming things there. You've got all these devices at the edge, plus all your photography, aerial or satellite and analysis and all the data the scientists are creating. This stuff is obviously important to you. And if you were to lose your data, just like any business, you would be in a disadvantaged situation, to say the least. And we've seen it, just in the last several months during this whole COVID thing. We've seen all sorts of ransomware attacks. We've seen all these problems that sometimes organizations just can't recover from. You guys, obviously failure is never an option, but what you're doing is so important to the ecosystem, and not just in Canada, but like you said, with Mexico and the US and other organizations you work with. So backup and recovery and just those fundamental basics are really important. I don't know, honestly, a lot about your Veeam backup situation because I got sidetracked with you and talked IoT sensors the whole time. But tell me a little bit about your backup situation and what you're doing with Veeam.
Well, with Veeam, we do almost everything. We're a full stack. As you know, we're very much the Veeam fanboys, and we really like their products. Their tagline of "It just works for us" is true. It's easy to use. It's simple. But really, the proof's in the pudding. And for us, compared to our old solution, our overhead in maintaining that whole backup ROI disaster recovery platform, it's just so much easier. There's so much less admin cost to making that work. So that's been a really good experience for us. And when we've had one experience in particular it was interesting because it happened kind of just after we switched into using Veeam sort of full time. We ran sort of in parallel for a little bit and then sort of cut off the old one and ran purely on Veeam. But shortly after that, we had one of our largest virtual server that happened to hold a lot of that GIS mapping data. It was about a 15 terabyte VM. So it's one of the larger ones that we had. We had a software corruption problem. And so in our minds, we're thinking, okay, so how are we going to go about doing this? And in the old world, we would have restored from a backup and mounted that and sort of spun it up again. But it was interesting because we'd just come back from the Veeam conference where they had that demo, if you remember, with the laptop that they dropped in the water, and then took the backup of that and spun it up virtually. And they
that was probably that sounds like a Rick Vanover joint right there. I think that was
really
it.
Cool. Like, oh, that's kind of wild. You just destroyed a full laptop, right? But it was to prove their point. But interestingly for us, shortly after that, we essentially came to the same conclusion that we can just restore the Veeam backup that we have for that VM virtually in our virtual environment, spin it up. And so within literally 5 minutes, and a lot of that was just discussing, is that going to work? Sure, let's try it. So that was really cool for us to be able to, what would have taken a long time previously to do the full restore or rebuild, was to just kind of flick a switch and do a restore from our backup, and then in the back end to do all the logistics that you have to do. But it was sort of real proof in the pudding that, hey, we had sort of the worst case scenario, short of a full server going offline, but being able to restore a fairly large VM in minutes was really cool.
Yeah, well, that does sound good, and that's how it's supposed to work. So the fact that it worked well for you is even better, right? And you guys are managing, I think you said, 2 physical data centers? Are you replicating and doing disaster recovery back and forth? What are you guys doing there?
Yeah, so we've moved, consolidated. Lots of things have happened within DU in the last couple of years, but we used to have our data center in our head office, and our head office is located about half an hour north of the city of Winnipeg. And because of its physical location, we had wireless transmission for our internet service. So while we had 100 meg symmetrical pipe, it was being saturated by all of the user traffic, by our backups, all the regional backups were all coming there, right? And so it was being saturated. So we looked at, do we increase the size of the pipe, or do we move the data center? And it was far cheaper to move the data center. So we pulled the data center out of Okanagan and we moved them into a professional enterprise grade data center that just got bought by Equinix. So that's our primary data center that's kind of in our backyard here in the city. And we've got a full rack and it's fantastic. Then we sorry, go ahead.
No, I was going to say, when you went through that movement, so if it's in your office, space is, important, but not that important. When you go to something like a data center, a colo, when you're paying per rack, the density does become important pretty quickly. Did you guys do anything to trim down your footprint or otherwise condense your platforms?
No, the interesting thing there is that our head office building is now 27 years old. And when it was first built, the data center room, the original data center room, was full of mainframes and tape libraries and backups. It was a massive room. And then it got smaller and smaller and smaller and smaller. And then 15 years or so ago, we shut off half of it and said, well, this is a lot of wasted space. Let's convert the rest of it into storage and we'll make this new data center room. And then that got smaller and smaller and smaller. So by the time that we moved 3 years ago into the data center, we could have actually fit in half a rack, but we needed a full rack for the power requirements of all of the various server pieces and backups and datriums, et cetera. So it really wasn't a capacity issue. It was a power constraint that we needed even more space than we actually needed.
Have you guys gone to HCI or any of these newfangled technologies, containers, any of that fun stuff?
Not in a serious way. I mean, everything's fully virtualized, as you might imagine, and our core data is all in the Datrium, which is a beautiful product. Unfortunately, it just got killed by Dell, so that's unfortunate. But it's a really nice environment for us to work in. So that's a kind of our primary data center in Winnipeg, and then we've got a secondary that's located in Calgary, and it's a full, almost cable for cable mirror image of the other. And then we've got a wavelength pipe that connects the two, so sub 5 millisecond, our own dedicated pipe. We can push VMs and imagery back and forth. Essentially, they think they're in the same data center, but they're not.
Yeah, that's pretty fun too. Well, the mission you guys are working on I think is really important. So as one last pitch, as we wrap this up, one of your biggest challenges is around fundraising. So for those that hear this and want to help protect the wetlands of Canada or the US or wherever they are, what's the best thing that people can do to help out your mission?
Go to ducks.ca or ducks.org, depending on which side of the border you're on, and there's a donate now button. Is by far the most efficient. If we're actually running fundraising events, then by all means go to the dinner, have some drinks, buy a print, and have a good time. But for now, until that starts to happen again, the cash donations are liquid gold for us.
All right. Well, we'll help spread the word. We'll put the links into the description. I actually bought a hat, a pretty cool flag hat with a little duck logo on the front of it. So I felt compelled. I'm not a hunter, but I just you guys are working on an important mission to take care of our environments, and we should support that. So we'll put the links in, and I do intend to check back with you on your IoT journey and see how that's going. But Andrew, great to chat with you again. I'm so pleased you decided to join us and could pull this off.
It's been fun.